to Miracle Learning Center. Today, we're going to look at the physics chapter, work done. Okay, work energy power. Okay, maybe we just write work. Okay, work has this formula: force times distance. But is it any distance? No, it's not any distance. It's distance in the direction of the force. Okay, do you know what's the units for force? The units for force is Newton. Okay, the units for force is Newton. And what's the units for distance? SI units for newtons. Sorry, SI units for distance is meter. So force times distance in the direction of the force. The work done is in, what's the SI unit for work done? Is in joules. So work done is force times distance in the direction of the force. Okay, let's look at what this means. Okay, so for example, I'm going to push this wall now. I'm going to push. See, I put in a lot of effort, but it didn't move. Okay, so it didn't move means the distance is 0. Did I do any work? Okay, so you're going to push the wall. The wall did not move. So is there any work done? This is no work done because the distance is 0. Anything multiplied by 0 is equals to 0 joules. So you push the wall, you put in a lot of effort, but it didn't move. So there's no work done. Does it mean everything that moves will have work done? Not necessary. Okay, so now you're going to school. And you're going to carry a bag to school. Okay, so you are going to carry a bag upwards. Okay, upwards. Carry a bag to school. Okay, let me show you a bag. Okay, I'm going to carry this bag to school. Okay, carry this bag. Carry this way. Carry to school. Okay, but what is the direction of the force? I'm carrying it in this way. Okay, means the force I'm exerting is up because I'm carrying the bag. But what is the direction that I'm moving? I am walking in this direction to school. So this is the direction of the force, but this is the direction that's moving, object's moving. So it's not in the direction of the force. So you put in a lot of effort and force to carry the bag to school, but you did not do any work because it's not in the direction of the force. Okay? So how would you consider work being done? Okay, there are many ways you can consider work being done, but it must always be in the direction of the force. Okay, how about if you push a trolley to school? Okay, so you exert a force. Okay, you're going to push it this way. You're going to push this way. See, this direction. Your force is this direction. And the distance is also in this direction. So you have the force, you have the distance in the direction of the force, same direction. So you will have work done. So if you push your trolley to school, okay, push your trolley to school, yes, you will have work done. How do you calculate the work done? Will be force times perpendicular distance. Force times distance in the direction of the force. Okay, force times distance in the direction of the force. Okay. Okay, let's do an example. For example, if you're climbing up the steps. Okay. So you're going to carry your bag now, remember? You're carrying the bag. And a bag has a mass of 50 kg. And they told you the height is 25 meters. And this side is 20 meters. Okay? So you're going to find the work done. So your work done has to be force in the direction, force multiplied by distance in the direction of the force. So what's the force? Okay, the force is this bag. They're going to carry it out. So 50 kg, you can't use 50 kg, right? You got to convert it to newtons. So 50 kg, how many newtons is that? 50 kg will be 500 newtons. And what's the distance? Are you going to take this distance or are you going to take this distance? Remember, distance has to be in the direction of the force. So the distance that's in the direction of the force should be this distance, which is 25. And it has to be meters, Newton meter. So it's 12500 joules, because joules is the SI units for work done. Okay. So that's all for work today. For more videos, go to miraclelearningcenter.com. I'm a specialist in maths and science. Thank you for watching this video.